This video is about simplifying exponential expressions. So in the previous 3 videos, we learned the rules of exponents. So how to simplify simple exponential expressions. Here we're going to continue with some more complicated examples. To simplify an exponential expression, we have to have all of these criteria met. So an exponential expression is simplified when each base occurs only once, no parentheses appear, no powers are raised to powers, and no negative or zero exponents appear. So all 4 of those criteria have to be met. And we're going to use the rules of exponents that we learned previously. So we have several examples here. First one is 9 to the 0 power. Now the rule here is that anything to the 0 power, so I could have b to the 0 power, that's going to equal to 1 as long as b is not 0. Well, the base here is 9, so it meets that criteria. So 9 to the 0 power would equal 1. The next one, I have this 3 out front, and then the fraction -3/7 raised to the 0 power. So again, I'm using this rule of exponents. B to the 0 power equals 1. So this would become 3. The -3/7 raised to the 0 power would give me a 1. 3 times 1 is 3. And that would be my final answer. All right, our next example is 2 squared over -3. So 2 is the only thing being squared. So I go ahead and do 2 times 2, which gives me a 4. The base of -3 has no exponent, so I'm just going to go ahead and leave that as -3. So you could write it as 4 over -3, or you could write it as -4/3. So you can put the negative in the numerator or the denominator or out front in front of your fraction. All right, and the next one is a negative and then parentheses 5/3 to the 3rd power. So that negative is out front. It's not included in the part that's being raised to the 3rd power. And I'm going to use the quotient rule, quotient to a power. So that would give me 5 to the 3rd power over 3 to the 3rd power. That power of 3 applies both to the numerator and the denominator. So that negative is out front. If you need to use the calculator, you can use the calculator to figure out your numbers. So I'm going to go ahead and do 5 raised to the 3rd power, and then 3 raised to the 3rd power. And if you missed this in the previous video, I'm using desmos.com/practice, and I'm using the scientific calculator. So that's desmos.com/practice. And you are allowed to use this calculator on your test, or you can use the TI-84. So 5 to the 3rd was 125. So I'll have 125 over 27 with that negative out front because I had the negative out front in the first place. All right, let's continue. I have 1 over 2p to the -4. Now, notice that the 2 is not raised to an exponent, so it's going to have to stay where it is. So I'll have 1 over 2. And then the p to the -4 is the same as p the 1 over p to the negative 4, I should say, is the same as p to the positive 4. So I'm going to bring the base p up to the numerator, and when I do, it changes the sign on the exponent. So that's using the rule that 1 over a base, I'll call it b, to the negative n is the same as b to the positive n. So that's the exponent rule that I'm using here. So the way I would write this in my final answer form would be p to the 4th over 2. All right, now I have parentheses 5w to the 4th, and then close the parentheses, raise the whole thing to the 3rd power. So I'm going to use more than one exponent rule here. The first one is when I have a product to a power. So I know that if I have a product, let me call it a times b in parentheses, raised to the nth power, that's the same as a to the n times b to the n, as long as it's multiplication inside the parentheses. So this would become 5 to the 3rd times w to the 3rd times v to the 4th to the 3rd. I would go ahead and figure out 5 to the 3rd. That gives me 125. 5 times 5 times 5. The w to the 3rd is good, so I'll write 125w to the 3rd, but now I still have these parentheses, and when I'm simplifying, I have to get rid of all the parentheses. So now I'll use the powers raised to a power rule. So we have the rule that if you have, let's call it b to the m to the nth power, that's equal to b to the m times n. So this would become v to the 4 times 3, which would give me v to the 12th power. And that would be my final answer. It's in simplified form now. So I used more than one of the rules of exponents to simplify this. All right, now I have negative 2x to the 4th, parentheses, negative x, and the negative is not raised to the power, so it's negative x to the 6th power. So this is really when that negative is not being raised to the power, that's really saying like negative 2 times x to the 4th times negative 1 times x to the 6th. That negative is not being raised to the 6th power. So negative and then x to the 6th is not the same as parentheses negative x raised to the 6th power. The negative out front with no parentheses there, that would be like a negative 1 and then x to the 6th power. Whereas this one, the negative x raised to the 6th power, that would be like a negative 1 to the 6th power and an x to the 6th power. Okay, so we have the one with the negative not being raised to the power. So what I can do is just rearrange the order a little bit. So that's like negative 2 times negative 1, and then x to the 4th times x to the 6th. So now I'm going to use the rule that says if I have b to the m times b to the n, that's equal to b to the m plus n. This is the exponent rule that I'm going to use to simplify this. So this would become positive 2, multiply the two numbers together, and then x to the 10, because x to the 4 times x to the 6 is x to the 4 plus 6, which is 10. So that would be my final answer for that one. All right, let's look at one more example. Oops, scrolled up a little too much. Let me go back down here. All right, so the last one is x to the 5th, y to the 4th, over x to the 6th, y. So what I'll do is I'll first consider the x to the 5th over x to the 6th. So those have the same base. And then I'll also do the y to the 4th over y. Now, when you just have a single variable and there's no exponent written, it's an implied 1 in the exponent. So I'm going to use the rule here that if I have b to the m divided by b to the n, that's equal to b to the m minus n. All right, so this will be x to the 5 minus 6 times y to the 4 minus 1. So you subtract the exponent that's on the denominator base. All right, so this becomes x to the negative 1 times y to the positive 3. Now I have to use the rule that if I have a base to a negative exponent, that's the same as 1 over that base raised to the positive exponent. So this will become, the x to the negative 1 will become 1 over x to the 1. And I'm multiplying by y to the 3rd. So my final answer will be written as y to the 3rd over x. That would be my final simplified answer. Now, these rules of exponents, you will have to memorize them. They'll come in later in the course when we're working with exponential functions, and they're important to know so that you can simplify exponential expressions.